What is open-loop control in control systems? Imagine turning on a fan or a toaster and not worrying about whether it actually reaches the right speed or browns the toast perfectly. That's the essence of open-loop control. It's a way to operate a system without constantly checking if it's doing what you want. Instead, you give it a set of instructions, and it just follows them. In electrical engineering, an open-loop control system has three main parts. First, there's an input signal, which could be a voltage or a command. Next, a controller or processor takes this input and converts it into a control signal. Finally, an actuator or output device, like a motor or heater, acts on that control signal to produce the desired effect. The key point is that the system does not look at the output while it's working. It doesn't measure or compare the actual result to the target. So, if something disturbs the system or the load changes, the system won't know or react. It just keeps doing what it was told, regardless of whether the output is correct or not. Open-loop systems are simple and cheaper because they don't need sensors or feedback mechanisms. They work well when the relationship between input and output is predictable and stable. For example, setting a microwave timer or turning on a light at a certain time works fine without feedback. If the load stays the same, the output will stay close to what you expect. But if the load varies, like if a fan encounters more resistance or a heater's environment changes, the output can drift away from the target. Since there's no feedback, the system can't correct itself. That's why open-loop control is best for applications where precision isn't critical or conditions don't change much. In contrast, closed-loop control systems use feedback to constantly monitor the output. They compare the actual output to the desired one and adjust the input accordingly. This makes them more accurate and adaptable but also more complex and costly. To sum up, open-loop control in control systems is a straightforward approach where the control action is based solely on predefined instructions. It's easy to set up and cost-effective but doesn't have the ability to correct errors caused by external disturbances or changes. It's perfect for simple tasks where conditions are stable and precision isn't a top priority.